Zi. Today, I want to talk about the smart pointer, about how it works and why it's quite important for a programmer. So usually for dynamic programming, we use a plain pointer to pointing to an allocated object. However, this method isn't safe since the system won't delete an object in the heap automatically. Instead, when it goes out of scope, we are responsible for manually deleting it. So let's see what happens when using a typical pointer. So okay, now we can see that we call the new operator. It assigns space for the demo class. We initialize this class for its member. Okay, so now we have created a demo class in a heap and has a pointer pointing to that. Now, when we manually delete it, it calls the destructor of the demo class. Okay, it finished. So this class is manually destructed. But programmers usually make mistakes. What can we do to hedge a potential risk of memory leaking? The resolution is a kind of smart pointer. A smart pointer is like a pointer. It's not like a pointer. It's an object. From the initialization, we can see that it requires a template of the class it points to. This will explain how it works. When assigned with a template, the smart pointer's destructor will include the feature to free the memory. At last, if this pointer goes out of the current scope, then it's in the stack. So the system will automatically destruct it, triggering the deletion in its destructor. The destructor in the smart pointer. So the memory will be freed and the allocated object, like the demo class, uh, dies as well. Let's see how it works. Okay, we just proceeded. We have entered the second example. Okay, so we created such a pointer, assign it to a demo class in the heap. We initialize the sample class. Okay, so this demo's smart pointer can also work similarly when it calls the members or the methods in the demo class. So we can see it can still speak. Now, it's going to leave the scope. But in this time, the the pointer will implicitly call its destructor and free the memory. Okay, so now this kind of smart pointer, we eliminate such a type of mistake that we may forget to free the memory after we use the allocated uh, space in the heap. So, and besides, this smart pointer acts similarly to a plain pointer. So we may care about the smart pointers in dynamic programming. So I hope this video will be helpful. Thanks.